Hello, everybody. So this is a very quick introduction to Gaffer. It's gonna be like a really quick and short video covering just the very basics of Gaffer. If you don't know anything at all about Gaffer, you can go to the gafferhq.org website, which is the official website for Gaffer. And in plain English, I would say that Gaffer is a scene assembler. Something similar than Katana or the assembling capabilities of something like Clarice or even Houdini. Basically, as you can see here, as they say, is a node-based VFX application that enables look development, lighting, compositing, asset assembling, and that sort of things. So basically, it's a container where you put all the content created in other software and all the content created in Gaffer. And basically you look the render and you finalize your shots, let's say that. Gaffer, as you can see here, is a free open source project. So you can actually download it for free and use it for free. There is a GitHub page here where you can download everything. You can compile it yourself. You can download binaries and so on. And well, Gaffer has been used, as you can see here, at Image Engine for a few years now. And they use it pretty much on every show, as far as I know, like as you can see here, Jurassic World, Lost in Space, Game of Thrones, and so on. There are different demos online about using Gaffer and different keynotes about how Image Engine has implemented as a Gaffer in their pipeline and so on. So everything should be here in gafferhq.org. So yeah, they have a documentation page, which is not huge at the moment, but at least they have some tutorials. They have some help about different nodes, node reference, scripting reference, and so on. So it's worth paying a visit to this website. There is a really nice Gaffer community as well, where the developers usually are very kind to answer all kind of questions. So you can come here and ask questions if you have, or just have a read through all the different threads. Gaffer at this moment is available, as far as I know, for Linux and Mac OS. I don't think it's available for Linux, sorry, for Windows just yet, which obviously makes a lot of sense because pretty much all the VFX facilities in the world uses Linux. So far, Gaffer supports Arnold Render, 3D Light, and Appleseed. If you don't know about Appleseed, just go to appleseedhq.net. And again, it's an open source project. So you just pay a visit to this website. When you install Gaffer out of the box, you already have Appleseed. If you want to use other render solutions like Arnold or 3D Light, you might have to install those renderers and change a few things in the in the Gaffer installation. So if you are not very tech savvy, like myself, the first thing you need to do is actually to install Gaffer. Once you have installed Gaffer, which is basically like downloading it from the website and put it in any directory, you have to do a couple of things in order to get Arnold Render to work. I'm going to be using Arnold Render on this demo. So the first thing you have to do is to edit your bus profile. In Mac OS, you can use, for example, a Nano and bus profile, and these are the two lines that you need to add to make Gaffer work first, and then to load Arnold Render. This first line is basically you don't really need to add this line, but if you don't, you will have to open Gaffer from the directory where it was installed. If you add this line, you can launch Gaffer with the command Gaffer. So if you have a new terminal and you type Gaffer, that's it. you will open Gaffer after this. If not, you have to go to the directory where Gaffer is installed and open it from there. I mean, it's not a big deal, but obviously this is easier and more comfortable. And the second line here, this is basically telling Gaffer where to find Arnold render. So you need to install Arnold SDK, put it whatever you want in your file system, and point to that path so Gaffer knows where to load Arnold render. So I'm gonna open Gaffer just by typing Gaffer here, and this is gonna open the Gaffer framework. Cool. So this is Gaffer, and as you can see, it looks very elegant and tidy. Everything is pretty well organized. You don't see a lot of buttons, which is great when you're dealing with a lot of stuff. So far so good. So this demo, as I said before, is going to be really quick, really basic. I'm not touching anything you can do with everything you can do with Gaffer, which is a lot of things. Hopefully in the future, I'm going to do like more demos with more advanced stuff and maybe some of my workflows or ways to approach tasks. But for now, it's going to be a really, really basic demo. Just letting you know, I'm not using Gaffer every day. I mean, I don't use Gaffer at work, but I've used in the past, working for other facilities, I've been using scene assemblers like Katana or Clarice, mainly those two ones, other proprietary tools as well. And recently I'm using also Houdini as a scene assembler. So I'm gonna try to extrapolate, let's say, the things that I do in those software here inside of Gaffer. For now, it's gonna be very simple, very basic, but at least you're gonna get an idea how to start setting up your scenes or your shots here in Gaffer. Well, the very first thing you have to do, obviously, is bring in your assets. So, well, we can have obviously different kind of assets. We can have characters, we can have environments, we can have any kind of utilities. For now, I'm gonna just bring a couple of assets that I have prepared in Maya. Usually, as a scene assembler, you usually don't generate a lot of content inside of a scene assembler. You basically generate all the content outside in another DCC application. So to bring assets, usually you're gonna work with Alembic files, Alembic caches. So I'm gonna bring my first Alembic by using a scene reader node. There are different ways of access to the different tools in Gaffer. One of them is just right click and look through the menus. So I don't usually use this. If I know what I'm looking for and I know the name or kind of the name, I just type here scene reader in this case, and this is my scene reader. So I'm gonna read an Alembic file using this guy. If I go here to the file name, I can look for my asset. The navigation window is not very convenient so far. So probably I need to type the path here, but I think I have my, no, I don't have it here, my bookmark. So I'm just gonna look for it. So I'm gonna be working on my username, documents. I have this directory here called Gaffer Learning. So now if I click on the bookmarks icon, I can basically add a bookmark. I'm gonna call this Gaffer Learning, so this is easier to find later on. Cool. So in my ABC directory here, I have different kind of Alembic caches, all of them exported from Maya. I have cameras, I have utils, I have this character here called Iron Patriot. So if I click OK, as you can see, what I'm loading here is just a bounding box of this asset, which is a very clever thing, because most of the time when you're working with a scene assembler, you only want to see bounding boxes. You don't want to load the full geometry in the viewport. You can if you want, but usually not going to happen. If you're working on, let's say you're look deving a character, yeah, why not? Characters are usually quite simple assets. But if you're working on a full shot and you have a lot of assets, a lot of characters, environment, and different utils, obviously you don't want to load any of that in the viewport, just like a rendering time. So this scene reader, as you can see in the viewport, I usually see whatever I have selected here in my graph editor. If I deselect that, I'm not loading anything in the viewport. If I select my scene reader again, yeah, I'm loading this bounding box. If you don't want that to happen, just click on this icon and that's gonna stick or lock to your current selection. So now if I deselect that node, yeah, I'm happy to select whatever nodes I have here later, and this is gonna look always to that particular node. I'm gonna disable it for now. I'm gonna change the node name. I'm gonna call this Iron Patriot group. And when I select the node, here I have the hierarchy view, which is some kind of outliner if you wanna put an example in Maya. So here you have the same structure that you exported from Maya, which in this case is the Iron Patriot group. If I click on this little arrow, I'm gonna see all the different groups, like the arms, the legs, and so on. And as you can see here, let's make this smaller, I'm selecting all those parts in the hierarchy view, and they get selected in the viewport as well. If you wanna see any of these, instead of bounding box, if you wanna see the full geometry, if you double click, you get that part. And obviously you have all the different objects here, so you can access to any of them. If I click on Shift, double click again, I go back to bounding box. If you want to see the whole hierarchy, just go to the top, Shift, double click, and now you see the full geometry here. So if I click here, yeah, I'm gonna look all the time at the full geometry. That's not gonna happen most of the time, so I'm gonna Shift, double click again, so I only see the bounding box. I'm gonna bring more assets. So I'm gonna take another scene reader and I'm going to bring, in this case, this thing here called Iron Patriot Utils. Let me rename this to Utils group. And if I take a look at the hierarchy view, I see that there is something called Utils group, and inside we have a gray sphere, chrome sphere, and Macbeth chart. You're probably gonna use these every single time you are look deving an asset or lighting a shot. So I'm gonna have these two guys here. Cool. So again, this is gonna be a very simple and basic demo, but if you had here a more complex scene, like a lighting shot, you would have a lot of different scene readers calling to your different Alembic caches. You can actually have just one, but that's gonna be probably a bit messy. So it is probably better to have different scene readers with different kind of Alembic caches, like environments, part of the environment, different characters, and so on. Okay, I'm gonna create now something called, sorry, not merge, but group. So this group node allows you to mix or merge or combine different scene readers. So if I connect my Iron Patriot here, and now I connect my utils here, you see that my bounding box has expanded, meaning that I have more stuff here. So if I take the group and first of all, let me rename it. I'm gonna rename it to something like assets group. So now if I Shift double click here, and sorry, I'm gonna rename it here as well. If I Shift double click, I see everything here. So as you can see, we have the character and we have the spheres and the Macbeth chart. Item Patriot here and utils here. And obviously I can go inside and I can see the Great Sphere, Chrome, Macbeth, and so on. One of the things that I like the most about Gaffer is that it's extremely fast. Loading big caches of tons of geometry is so fast. So I'm so happy that we can use Gaffer for scene assembler because it's extremely fast. Right, so let's keep working on this. Actually, yeah, I'm going to double click here. I'm going to lock the viewport because I want to see everything. Because I want to use, I want to create a ground plane. So in this case, instead of bringing an Alembic cache, I'm just going to create a plane and connect it here. And yeah, it's here in the center of the wall. So I'm just going to the transform tab, and here I can just rotate it like 90 degrees. In this axis, make it a bit bigger, something like that, maybe a bit more. Cool, nice. I don't want to see this anymore. Okay, so these are all my assets. For this demo, I think this is gonna be good enough. Obviously, we could have like a really big structure here. The next thing I'm going to do is I'm gonna create a camera. If you're working on a real shot, chances of importing an Alembic camera are pretty high, right? You're not creating cameras in a scene assembler. You're importing cameras that come from layout or set dressing or any other department. But for this demo, I'm just gonna create a camera here. So there's a camera node that you can create here. I'm gonna rename this to render camera. There are different settings like type of projection, field of view, and so on. We don't need to worry about that now. And again, most of the time that's gonna be given by the Alembic cache file. What I like to do is, because usually, especially when you're look deving an asset, you usually have different cameras like the full body camera or the head camera and so on. So I like to put those in a group. So let me create a new group here, connect my camera, and just rename this group to something like cameras. And in this case, I only have one camera, but let's say you have 25 cameras, all of them would be connected here, and this is gonna be like a container for all of them. Okay, so in this group, if you go to the hierarchy view, again, you can see that there is something called cameras, which is the group. And then inside there is something called render camera that I can actually select in the viewport. I can move it or I can do whatever I want with this camera. So let me translate it a little bit so we can see the character like 10 units high. And let's move it back a little bit so we can see the character. All right, so I'm gonna create another group node. And here I'm going to combine my assets on my cameras. And I don't know, let's call this group something like shot 0001. So 01. So now in this shot, I can actually expand on the hierarchy view, and I see that I have the assets on the cameras. to keep consistency, I'm actually going to rename this to something like cameras group. So now if I double click here, we can see everything. We can actually now go to this little icon here and look through the camera. Okay, if you want, we can stick to this view and keep working on this shot, or this look depth scene in this case. Okay, so we have assets, we have cameras, we also need lights, of course. So in this case, from the Arnold menu, we can access to all the different lights, or if you know the names, we can just type it here. Let's use an Skydome light. Just be careful because we have Arnold, but we have also Appleseed render, which has also lights that maybe they are called kind of the same. So as you can see here, when I type Skydome, there's a Skydome light and there's this other AI Skydome. They are different lights. So for Arnold, stick to AI Skydome light. So this Skydome light has all the common parameters that you might expect for a Skydome light, like intensity, color, exposure, texture map, and so on. Not gonna talk about Arnold properties, Arnold settings, Arnold whatever. In this video, this is just a very quick and basic introduction to Gaffer, but maybe in the future I'm covering how to set up properly all the Arnold settings here inside of Gaffer. So again, this is a very quick and basic setup, but if this would be like a real look development template or like a lighting shot, I would be placing all my lights inside of a group. So let's call this group lights group. And okay, let's stick to this for now. And this lights group obviously is going to be connected also to my shot 001. So now, as you can see, we have a light in the middle of the scene. As you can see here. We can take the Skydome light and we can move it, or we can do whatever. So if we translate it like 5 units, you see that now it's here. And if I move it another 5, in this axis, you can see I have the light here. In this particular case, we don't care at all about the position of this light because this is a Skydome light. So the light is coming like everywhere. This is an environment light. All right. Next thing. Obviously, right now this doesn't have any textures. This is just a plain color, which is not very interesting. So we need to connect an HDRI image to this Skydome light. To do so, just create an image, AI image node. In the file name, we can look for an HDRI. So let me go to HDR library that I have here, and I have different HDRs here. Let me just select this one, and I'm gonna connect it to the color of the Skydome. So now here, as you can see, the color is mapped with something. So I can really change the color here because we have this image connected. This image has different kind of transformations, or actually it's not in the image, it's in the Skydome. So here where it says format, it says angular by default. We don't want to use angular projection. We want to use lat long because we're using an equirectangular map. I think it's a good time to save the script. So I'm gonna rename this to something like item Patriot live demo version 1. Okay, great. Let's see what's next. We have assets, we have cameras, we have lights. So I guess the next thing is actually gonna be shaders. That's what we're missing so far. So to create shaders, we need something called shader assignment. Let's connect this guy here. And in this shader assignment, we have two different inputs. One is for shaders and the other one is for filters. We're gonna talk about filters in a minute. We need a shader first, so let's create a standard shader, standard Arnold surface shader. And let's connect this one here. Again, all these settings are the very common settings of the Arnold surface shader. The only thing I want to change here is the base color. I want to use something like kind of a neutral gray, something like that. Cool. So I think we are ready to render this this shot or this looked-up template or whatever you want to call this. So to render this, we need a few nodes here. The very first one is called Arnold render Arnold options. So these are the global Arnold render options. Common settings again, like sampling, ray depth, subdivision, filtering, and so on. We don't need to talk about this just yet, maybe in the future, but if you're familiar with Arnold, you already know all these settings. The next node that we need in order to be able to render is something called standard options. And this is standard options settings for the global project, for the project globals. We have something like camera, we have resolution, we have motion blur, and so on. We can again talk about this in the future. For now, the only thing we want to do here is establish our rendering camera and establish the resolution. So click on this icon to activate the camera, and we can look for our camera, which is in the sorry, I think I renamed this so badly. So let me change this to shot 01. Okay, so now in standard options, I'm going to look for my camera in shot 1, camera groups, render camera. Okay, where are we? Yeah, I need to change the camera here. That's why I have a warning here. So browse. I don't see my camera no more. Why is that? Just want to see that everything is okay here. It seems to be okay. Okay, yeah, I don't know why it's complaining. Let me just do a very quick thing here. I don't think it's complaining for real, but just in case, yeah, it's not complaining for real. As you can see, it's all right now. So I'm gonna rename this again to assets group. Okay, so again, standard options, set the camera, set the resolution, do something like 1280 by 720. Okay, all good. Okay, next step, we need, we have the Arnold options node, standard options. We need something called output, and this is gonna take care of all the outputs that we need for our render, which is, in this case, I mean, this is a very basic scene again, so we only need a beauty pass. So let's go to interactive beauty, but we can add as many as we need, and this is something that I'm gonna cover in the future. Like in the Arnold renderer here, we can access to all the different components. As you can see here, different kind of direct and indirect components, diffuse, transmission, subsurface scattering, and so on. We're gonna take care of this in the future. All right, so we can enable and disable any component here. And then we have all the options here that most of the time, this is perfectly fine. We don't need to take care of this. All right, next node that we need in order to render this is something called interactive Arnold renderer. So if we press play here, we're gonna be rendering. But before, we need a catalog. With this catalog, we can actually see what is being rendered. So I'm going to select the catalog and click on lock viewport. So this doesn't go away. And now click on interactive Arnold renderer and click on play. As you can see here, everything is rendering fine. If we press F, we frame everything. If we press home, we see the render with 1:1 resolution. Cool. I'm going to my light here, my skydome light, and I'm going to rotate this a little bit. I just want to have the light coming from the left side of the screen. Yeah, something like that. So, okay, we are ready to keep working on this. I'm just going to do a couple of few things more that I think they are very basic for a look dev setup, but this is mostly the setup that I wanted to create. I'm going to save this. Okay, so next step, I just want to add a couple more of these shader assignments because I want to show you how to filter by asset name or by properties or components, or just using wildcards to point shaders to the right asset or the right part of the asset. Before doing that, I'm gonna try to make this a little bit more organized and tidy. So I'm just gonna create a couple of backdrops. And I'm gonna put these guys inside of a backdrop. I'm gonna call these assets. I'm gonna call these lights. And this is gonna be my cameras. Okay, so this is looking better now. I'm going to move these down a little bit. And I usually do my shader assignments before. So I'm going to cut these nodes, paste them here, and reconnect this guy. So let's call this shader assignment something like all. So we know that this is affecting to everything that we have in the scene in terms of assets. Okay, so let me create another shader assignment. This shader assignment is going to be called something like Chrome Sphere. I'm going to create a new standard surface shader and connect it here. So this is standard surface shader. Let me rename it to something like Chrome Sphere Surface. I'm going to change some of the properties. Like I don't want any diffuse component because this is going to be Chrome. And in the specular, let's use something crazy like 20. In the index refraction. Okay. And nothing is happening, and that's because I have another shader assignment here that is also affecting to everything. So let me disable this for now. If I select the node and press D, I'm disabling this shader assignment, and this is the one that is affecting to my entire scene now. If I disable this as well, as you can see, I don't have any shading. So we have one of these spheres is supposed to be made of Chrome. If I select my group, you see there is something here called Chrome Sphere. So how can I point this shader assignment only to that object, to the Chrome Sphere geometry? We can just go and create a path filter node, connect this one to the filter of my shader assignment, and now nothing is assigned. I'm going to activate again this shader assignment that I have here, so everything gets that material. Actually, I'm going to change this to a color like this. So we see if we're missing any shader assignments, this is going to be assigned to that. So it's so easy to identify any object without any shading component. Okay, cool. Next thing, in this path filter, I can create a new path, a new rule here, and I need to point to that particular sphere. So again, if I go to my assets group and if I select the Chrome Sphere geometry, if I go here to the scene inspector, I can see the location of that sphere, which is assets group, utils group, something called Chrome Sphere geometry. So in my rule here, I want to go to assets group. I want to go to utils group, right? It's assets group, utils group, and then I have a Chrome Sphere geometry. So I can type here something like Chrome Sphere geometry. Let me check everything is okay. Yeah, it's okay. Sorry, I just have this one here affecting to everything. So I'm gonna move this guy. I'm gonna paste it here. Okay. So now, yeah, as you can see, filtering by Chrome Sphere geometry, that Chrome shader is being applied to my Chrome Sphere. All right. Instead of pointing to the Chrome Sphere geometry, I can use wildcards here. And most of the time, you're gonna find yourself using wildcards. So if I type here Chrome, this shader is gonna be assigned to anything that is called Chrome, which in this case is just a sphere. But if we had like, I don't know, 25 different pieces made of metal and they are called metal, the only thing I have to do here is just type star metal star, and absolutely everything that is called metal inside of assets group, utils group is going to be assigned the Chrome material in this case. Okay, that's right. Let's create another shader assignment. And this is actually going to be called gray sphere. I'm going to create another standard surface material and connect it here. And rename this to gray sphere surface. I don't want any specular component here. I only want a neutral gray color, like that. And again, I want to filter that so it only gets assigned to that sphere. And that sphere is in the assets group, in the utils group, and I'm going to assign that material to everything that is called gray. And that's it. We have the shader assigned perfectly here. I'm gonna make more room here. I'm going to create another another shader assignment. And this is going to be my Macbeth chart. So we're going to need another path filter, and we're going to need another standard surface shader, which I'm going to call Macbeth surface. Get rid of the specular for now. And change the color to something that I can identify quite easily, like this. Connect it here and filter by path. That again is going to be called assets group, utils group, and because I don't remember the name exactly, I'm going to assign to anything called Macbeth. That's it. We need a texture for this Macbeth, so I'm going to use an AI image node. And then I'm going to select my texture. Connect this to the base color, and that's it. The texture is assigned. All right, so I'm gonna change this material, which is this pink color. I'm gonna, I don't know, I'm gonna use something more like gray color. This is gonna be my plane, the grid that I have here. I'm gonna save this, and I'm gonna do my latest shader assignment, which is going to be a shader for the entire character. Obviously, this is not what you would do in a real situation. If you're looking at this asset, you're probably gonna use different shaders and you're gonna layer them and do different operations, different mixes, and so on. That's something that we can deal with in the future. But for now, for this particular demo, I'm just going to assign a shader for the whole character. So this is going to be called item patriot. I'm going to create another standard surface, which I can call metal surface, assign this to my item patriot, create a path filter, and now I need to look for my character, and my character lives under the assets group, item patriot group. So to assign a shader to the whole character, the only thing I have to do is using wildcards again. If I called my assets group Iron Patriot group star, it should be assigned by now if everything is correct here. So let me change something here. So let me put 0 here. So now it's not being assigned to my Iron Patriot. Let's see why not. I think I made a typo here. Yep, not I don't, but I don't. Okay, still not working. Why not? Oh yeah, because I still have this guy here being assigned to everything. So I'm going to just create a path filter again. And I want to assign this only to the grid. So let's rename this guy to assets group. Plain. Okay, so now everything's working fine. So what I'm missing is, well, I'm just gonna tweak this shader a little bit. I don't want any diffuse component here. Obviously, I'm not going to look depth this character, but I just want to do something very basic like this. That's it. Okay, so all of these would be my look depth. If we press space, we can maximize a window. All right, so as a basic introduction, I would say this is good enough. We learned how to bring assets, how to create cameras, how to create geometry inside of Gaffer, how to create lights, and how to assign shaders, and basically how to output beauty render. There are a lot of more things that we can cover in the future, like proper shading templates, creating shots, bringing cameras, and bringing volumes. I mean, like using it for real, right? This is just a very quick and basic introduction, but hopefully this is good enough for you so you can get an idea of things you can do with Gaffer, and most important, how you can get to work with Gaffer in I don't know, in 5 minutes, right? Just like 5, 6, 7 nodes that we reviewed in this demo, but with those you can already start working with Gaffer. Again, Gaffer is extremely fast, so whatever you do is going to be updated automatically. You can easily play with cameras, and you can actually see how fast it is to do any operation here. Okay, so yeah, again, thanks for watching, and let me know if you have any questions, but most important, just download Gaffer, play with it around, and go to the Gaffer community, ask questions if you have, and just have fun. Bye.